Alright guys, let's go through this dynamic measurement option we have in Geometer Sketchpad that I think is pretty cool. As you will see here, this is actually the object used in the Ptolemy's theorem for cyclic quadrilaterals. That means quadrilaterals that can be circumscribed by a circle. So what the big idea here is that if we do transformations, we have a maintained dimension here. And the reason for that is, according to Ptolemy, a mathematician, geometer from about a bazillion years ago, as they all are, says that in order for a quadrilateral to be cyclic, it must maintain the quality of the dimensions of the opposite outside lines, the opposite side lines, the product of those two lines plus the product of these two lines must equal the product of these two lines. Okay, so as you can see here, we've got that situation set up. We've got AB times CD, ABCD, and then we got DABC. That's, here we go, DABC. And so then we got ACBD, ACBD. That looks pretty good. So basically what we're trying to accomplish here is saying that no matter what we do here, this dimension and this dimension are going to stay the same. That is a pretty good visual representation of Ptolemy's idea, and even though I probably said it before in these videos, it's certainly not a proof. As you have probably learned by now, proofs are very number shy. This wouldn't sell as a proof to any sort of mathematics kind of guy or mathematician or math journals or anything like that, but it is a very good visual representation. We can animate our object, and as it's animating, these dimensions are being changed, and so we'll go ahead and stop that animation. And so now we'll go ahead and make this applicable to one of our devices, one of our objects, I guess I should more properly say. As you can see here, when we change our parent triangle, we are maintaining an equality between the area of the large square built off of the hypotenuse and the sum of the area of the two other squares built off of the base and the leg. So no matter what we do, we keep doing that. We keep this equality, and that's pretty cool. That's what we're looking for. So now let's see here where I can go to. There we go. Now let me just kind of get rid of all this and start from scratch. Whoa, couldn't do that, could we? Sorry about that. Forgot I needed to leave that parent rectangle in place. Parent triangle. So, but I can delete that, and I'll just leave this. This is just an action button that hides the squares. So I think most of us know how to do that by now, but you can certainly ask me for a tutorial on it if you don't. Now let's see here. We want to highlight this and then measure the area, and then we want to highlight both of these and measure the area. And so there we have them. And let's go ahead and move those over here so they're a little bit more accessible to us. Now, what we like to do is see what the sum of these two areas are relative to this one. All we have to do is bring up the calculator, and to do that, we just click number, calculate, and then, kind of a cool thing, basically what we have to do is say we want to calculate that plus that. Okay, so there we go. We got another one. There's a equality there. We can go ahead and hide these if we like, and so let's go ahead and do that. Hide those off, and then line these up as best we can. This is sort of problematic in some ways because if you get them out of line, it's almost impossible to get them back in line. Anyway, so that's what we got. Looky there, we're maintaining that equality no matter what we do, and that's what we like. So there you go, guys. There's the dynamic measure trick, and I hope that helps you. And of course, if you have any other questions, all you got to do is ask. Okay, guys, see you in the next one.